Hello everyone and welcome back to the Hybrid Friends. You maybe already watched the big video about doing BOM and hardware reviews that I did together with Steve. To make it a bit easier, we decided to split up the 1 hour video in a few smaller ones so that you can concentrate on the parts you may want to rewatch or want to look again. So enjoy the short video coming about the hardware reviews and what we're thinking. And yeah, leave us comments, leave us likes, subscribe our channel. I said if you have questions, just comment below, write us on LinkedIn, or if you're working with us as a team already, just ping us directly. So have a great one, enjoy, and thank you. Okay, why do we ask about NICs? So especially Bernard could tell stories about that.
Yeah. So with the NICs, the network, because it's hyper converged, is key. Because everything's reliant on the network: your storage, your compute, your management. So basically, the first thing we look for is that the NICs are within the Windows Server catalog. So again, they need to be supported via with the latest server operating system, so that you get all of the features that are required. And then additionally to that, there are three types of traffic which the NICs need to support. So they're compute, storage, and management. Now, depending on which design you go for, you may need a NIC. So if you went fully converged and you just had a pair of NICs, which you then had a set switch and you had your storage, your management, your compute, that NIC would need to support all of those standards. But what you can do is you can then break that down to go and break your traffic up so that you have dedicated NICs for your storage. So again, they would just need the storage capabilities and the validation that they support the storage aspect. You can have separate for management, and they would need that. And then again, compute, you would need one compute on NICs that support the compute standards. But you can then start to mix and match. So you could go for dedicated storage, so pair 2 ports for storage per node, but then you could have 2 ports which you use for compute and management. So again, it's key that you tick all of those boxes, that you support those three types. Also, the next thing is about the NICs need to be symmetrical. So you need to have the same NICs going down as far as make, model, firmware, and driver versions on there. Again, that's because to create the highly available switches, the set switch, those need to be symmetrical. And again, this goes back to those validated and integrated systems. They will make sure or can help make sure that they are available. So as I said, there's sorry, go ahead.
Maybe also worth mentioning here, even if they have the same firmware, if they have the same chip and so on, you can also not mix LAN on motherboard chips with PCIe chips or PCIe NICs, because they're often not, let's say, connected to the CPU in the same way. With some servers, with some motherboards, those systems, especially when you have an Intel, they have a chipset on motherboard which expands the PCI lanes, so they can add additional cards. And the LAN motherboard is normally directly integrated into the CPU. So please be aware that you can also not mix and match PCI and LAN on the motherboard. Here in this case, from a vendor perspective, especially when talking about RDMA, so without RDMA, I think everything is perfectly fine. But Steve, we know we had some trouble, for example, with the Intel RDMA cards recently due to driver and firmware issues, and we are still seeing that. So we have August 2023, and we are still seeing some driver issues. That's one thing we also mentioning to our customers. It may work or may not. So that so a good bet here when working with RDMA cards is still NVIDIA Mellanox. Marvel is doing a good job, and also Broadcom. Intel, most of the hardware partners already removed the Intel cards from their offerings. But if you're seeing those really question your partner if that issue with the drivers and firmware is already resolved when watching that video and when talking to your partner. If not, exchange the cards. And maybe one thing, I don't know if it's only me, but Steve, driving that one. So we are not only talking about the high capacity cards, like the 10, 25 gig cards, but normally every motherboard has 2 1 gig LAN on motherboards.
Yep.
I'm a friend of using those for management, heartbeat, and maybe backup or something like that. Would it be and also a recommendation you would drive to use every port you have available on your system, or is just leave them empty?
Yeah. So I think if those ports are there, make use of them. As you say, if you move things like management and even back up onto some onboard ports, which may be only 1 gig, that gives you the option. You're freeing up bandwidth on your other ports. So again, you're not taking some of the bandwidth for backup traffic from your compute, the cards which are dedicated for compute. So yeah, I think if those ports are there and are available, make use of them. Again, it can depend on, because sometimes customers are using existing switches, so port availability could be limited. So again, it may be that you don't have capacity in your switches, in your top of rack switches, but yeah, I think if you've got the ability to use those ports, yeah, definitely. But again, if it's something like just maybe a 1 gig port, keep that for heartbeat or management or backup, and then keep your higher bandwidth ports as 10, 25 gig ports for storage, for your compute, for replication if you're going for a stretch cluster. Yeah, so I would definitely look to use those where possible.
It's also saving up some money. So if you're looking on the port prices for the larger ports, you will see that, for example, a 1 gig port is it's normally only an operational cost from a few cents per month. I think in Germany, I don't know how it is in the UK. It's 75 cents per month for a 1 gig port. And when you look onto a 25 gig port, it's around €4 per month, which is the calculated data center cost per port. And if you can free up those with cheaper ports and then have more bandwidth available, it's more or less also a cost saving on the long term.
Yeah, that's it. So I think the next bit of the diagram, it starts to get a little bit although we're discussing hardware, it starts to look at your design. So when it comes to your storage, you can go switched or switchless. Now, depending on if you go switchless, we're directly connecting the nodes, so the number of network ports that you need starts to increase, and the more number of nodes that you're having in your cluster needs to increase, so that you can get the direct connectivity between each of the nodes for the storage network. So again, this part of the diagram sort of goes through that. If you're going for 4 or more nodes and it's switchless, that really you need to maybe reconsider your switch design and go for a switched storage network. Again, then go across if you have 3 nodes, that ideally you need to be having 6 or more ports so that you can get your cross connections for your for the storage and have a full mesh for your storage, so you can tolerate some of those links going down but not lose the connectivity. Again, if you're going 4 or 5 ports, again, it will still work, but you're not going to be able to have that full mesh for your switch list configuration. And then again, if you've got only 3 or less ports and you've got a 3-node system, you can't go switchless, because you need to have dedicated storage, and then you should be still looking at 2 ports for computer management to give you that high availability and resiliency.
It's also not even if it's working, it's not recommended, because if you for example needing 6 ports for full mesh configuration, you would also need to have 6 additional network subnetworks you need to manage, need to correctly cable and set on the other sides. So it doesn't make any sense to go switchless with more than 3 nodes.
Yeah. I think the benefits of going switchless, so you sort of not having to have switches that support the switch configuration and things like that. Well, I'd say once you start, as you add extra nodes, you're needing to add the number of ports you need to start to go exponentially, so that it's not just a case of adding 2 more ports when you add a new node. You need to make sure that every node has at least one direct connection to every other node, and really you need to be looking for 2 connections. So again, it starts to become the cabling and cable management becomes difficult. The carving up your subnets and your networking becomes difficult. So 2 or 3 nodes, go switchless. If you need to, but anything above that, we would definitely recommend to go for a switch configuration.
Yeah.
You can migrate between the 2, but again, that is going to be a lot of work, potentially some downtime to the customer while you're recabling things and adding extra NICs. So again, it's maybe better to consider that at the beginning, so that you're ready and can. So if you need to add those extra nodes, you're able to without too much additional work.
So staying with our scenarios, so where you maybe see switches, where you maybe see switched. So switches we're seeing really often in edge scenarios, where we have a small cluster running somewhere at the edge, or in a small medium business company who only has a few nodes, or even a stretch scenario where you have 2 or 3 nodes on one side, or 2 and 3 nodes on the other side. So there we often see switchless when we're going to larger deployments within a data center, or even within larger size. We are seeing more the switched configuration. Also, when you look again on the cost perspective, those Mellanox cards those Marvel cards are highly expensive, and as you add more cards, maybe a switch becomes more affordable than adding more cards.
Yeah.
Also calculating the management overhead, possible downtimes, and also a migration or a zero downtime migration from one to another is possible, with some really getting your brain and head around that, but it's possible. But yeah, as you already said, it's better planning ahead and planning the expansions you maybe want to do in 1 year, 1.5 year, already in your design now, to make an expansion easier, and also saving labor time. Again, it's also one thought process we always have when we go through those review processes and discussing about the customer's future with those clusters, with those systems, is what are your plans for the futures? Okay, what do you need to invest in labor time when you want to upgrade it later on in 1.5 year? Maybe is the person who did the whole configuration still there? So let's say you get someone from Dell, configure the whole cluster, knows everything, and he will not be available 1.5 year to help you increasing the cluster, redo the cabling and so on. Maybe also losing documentation, which is, IT documentation. We all do it right, but we lose it at some point in our careers. So always calculate that in mind. Always calculate not the best case scenario. I'm personally a worst case guy. and calculate those labor costs into your current offers. how much would it cost me if Steve would come for 2 weeks to do the recabling with 1,500 British pounds per day or per hour, Steve per hour. So yeah, maybe it's affordable to have that switch and these stack cables already.
Yeah. Yeah, again, I think with this, it's looking to the future. Don't look at your immediate requirements. Maybe have a look how you would expand and move forward into the future. So I think the other consideration, so we've covered off switchless, is going for a switched configuration. So as we go through, you can do a switched configuration with only 2 NICs. So you would have a fully converged network topology where you would create a set switch with those 2 NICs, and then you would have storage interfaces and your management and your compute interfaces all on that set switch. But with that, what we do recommend is that really should be 25 gig or more, basically just so that you've got enough bandwidth for your storage and your compute, and you don't want those two to interfere with one another. There are QoS policies where you reserve certain amounts of bandwidth for storage and certain for your management, and then the rest is available for compute. But again, we find that is to go for those, even with just a 2-node switched environment would be go for 25 gig NICs. The next one is if you've got 4 or more NICs.
Maybe add a comment here at this point. Again, back to my retail example. Yes, so maybe also 10 gig is fine, but it's really also depending on your workload. If you're just running a domain controller and maybe some system for your cashier, or maybe just a file server, 10 gig might be okay. But I would really recommend to talk to a partner and do some quick IO calculations if that works out for you. I said what we encountered is, even with a 10 gig on 2-node, having a lot of machines running, having file servers running, having data centers running, especially with those servers like the AMD EPIC servers where you have really hundreds of cores in one system, a lot of memory in one system, more than 2 terabyte right now. If you really full stack that one, it could be that you have 50, 70 virtual machines running on one system with a high amount of changes, and then having a hyper-converged configuration that could really have an impact on your storage I/O.
Yep.
And let's really also look onto your workload. And is that with a fully blown node, it could happen that you're ending up with a demand for more network traffic in fully converged. I said if it's just sitting down there in a shelf, serving as a domain controller and maybe for your cache systems, 10 gig might be fine. But I said if there's more planned in the future, you maybe will run in a bottleneck with that. That's why we always look for the 25.
Yep. Yeah, and then the next option is when you've got more NICs available, so 4 or more NICs. So again, this is where what you would do is if you had 4 NICs, the first thing you would look to do is break away and have dedicated NICs for your storage. So this is what we're going to look at. So the first part, mainly is your storage NICs. That really, if you've got 3 or more nodes, that what you should look is again be looking for those up sort of 25 gig or above NICs, just so you can handle the amount of storage replication that's needed between those nodes. If you're just going for you just have a 2-node system, we would recommend a minimum of 10 gig for those storage networks. Again, just so you haven't got any consideration about are you going to have enough bandwidth for all of the storage traffic. And then what you would do is you would use 2 NICs for storage, and then what you could look to then do is however many other NICs you've got, as Flo mentioned, you may have 2 10 gig NICs and 2 1 gig NICs. what you might look to do is create a set switch with your two 10 gig NICs and have that just for your compute, and then use your 1 gig NICs for your heartbeat and your cluster management. And then, or what you could do is go for a set switch, and if you only had 2 extra ports, and have compute and management on those NICs as well. So again, it's just really the key one is around the storage network. If you're only 2 nodes, yeah, so you most likely get away with having 10 gig NICs. But three nodes or above, we would definitely recommend going 25 gig on those storage NICs.
Perfect. So in the next step, you're mentioning stretched cluster. How does the stretched cluster impact our decision making when it comes to especially network design?
Yeah, yes. So I think the first key thing is with the stretched cluster between the 2 sides or your 2 locations, you need to have sub 5 milliseconds round trip time. So again, that is a key thing that you need to consider, is that it doesn't matter what hardware you purchase for each site. If you can't provide sub 5 milliseconds round trip time, a stretched cluster isn't going to really work out for you.
Or
and
an
then
active stretch cluster, basically.
Yes.
Where both sides are active. So if you would pass these 5 milliseconds round trip, then it would be an active standby where one side is serving your machines and the other side is more or less idling around until failover.
Yes. Yeah. So, and then when it comes to the hardware side of things, so what you need to consider is that you need to create some separate, or you need to have some interfaces for your replication traffic. So again, it's advised to have 2 per node. What you can do is you can either have dedicated, so that you can that you just have 2 dedicated NICs, similarly the way you could do with storage, which would only handle your replication traffic between the 2 sides of your cluster. Or the other option that you have is that you could have a set switch. So you could, if you had 4 NICs, you could go 2 dedicated for storage, and then you would have your set switch, which would be your compute and your management. Then you need to make a decision where you're going to put your replication networks. You could either add a set switch to your storage and then use those 2 NICs for storage and replication, but potentially you're then adding a software layer of your storage network. So if the storage performance is key, that may not be appropriate. The other option is to add some additional virtual interfaces to your computer management switch. But again, with with both of those options, you need to validate: are you going to have enough bandwidth on those interfaces for all of the traffic types that you require, such as so again, you could end up having compute, replication, and management on one interface. Now, if that's a 10 gig interface, you may struggle, because when we think with a stretch cluster, every write that is sent to the storage is also sent across the replicate interface. So if you've got a 25 gig pair of storage interfaces, it is theoretical that you could get 20 gigabytes of traffic going through that storage interface, and that needs to be available for replica as well. If not, the replication can fall behind. It can catch up, but again, if you're falling behind on the replication too much, it can have an impact on the performance of your storage, because with the stretch clusters, especially with synchronous, the write isn't confirmed until the replica has been written to as well. So again, that is key. And again, the decision we have here is, again, do you have enough network capacity to handle that replication if it is a shared, if you don't have dedicated replication interfaces?
Just go again, doing a short scenario thought around that one is, just imagine you're already during business hours, your network interfaces are always at the edge, always struggling, and you have your replication is not catching up. Normally, via nighttime hours, you're catching up. You're perfectly fine after nighttime, and you're perfectly fine when you start your business. But maybe at some day or at some point, you change the cleaning lady, and she has a different rhythm of business, and does not know where she can put her vacuum in, and she's just pulling the plug from your rack, and your servers are going down, and your remote side is coming up because of that. It could happen that your replication wasn't catching up and you have maybe an older state from a few minutes ago. And that could just destroy your all over experience. Another important point to mention here is not every workload needs to be replicated. So if you want to save bandwidth on your interfaces, not every workload needs to be replicated. Everything which can build an application cluster shouldn't be replicated. So like Active Directory is the perfect example for that. Active Directory domain controllers does not like to be replicated. Just have a volume which is not replicated to the other side. Put your one domain controller there and have the same on the other side, or have it outside of something of your cluster, and then use it there. But do not replicate workloads which can serve a cluster, or normally you call it application cluster, outside of any replication or disaster mechanism. Just try to keep them outside of those areas. It could harm you more than it helps.
Yeah. So again, just to build that, have those stretch volumes as being a catch-all. So if you have any applications that you can't do high availability at an application level, that's when you could look to use those stretch clusters, and again, that could help reduce that amount of replication traffic.
Hey everyone, thank you for watching that video, and if you liked it, subscribe our channel. There will be more, and yeah, leave us comments with questions, topics you want to see, and yeah, enjoy your time. Thank you so much. Bye.